Hello, Algebra 3. This is our video key for section 7.4. As we were dealing with applications of exponential functions, and in this assignment we were given 5 problems that had to deal with exponential growth or exponential decay. So let's go ahead and get started and look at question number 1. Here's question number 1. Vanessa invested $2,500 into an account that will increase in value by 3.5% each year. Write an exponential function to model the situation, then find the value of the investment after 20 years. So I've written the growth and decay functions over here. So the first thing we have to decide is which one are we going to use, growth or decay? Is our investment going up? Is it going down? Well, we have this word here, increase, which tells us that we're going to be growing. So we're going to use our growth function right here. Now we just have to identify our A, our R, and our T. So A is our initial amount. Our initial amount is right here, $2,500, $2,500. Our growth rate is right here, 3.5%. We're going to write that as a decimal, so that's 0.035. And finally, time. Well, first we're going to write an exponential function, so time is going to be T. But then ultimately, the second part of our question, we're going to have to find the value of that investment after 20 years. So that's when T will equal 20. All right, so we got all our values here. Let's plug it into our growth function so we can get our general function to model the situation. So we're going to have f of t equals A, which is 2,500, times 1 plus R, so that's 1 plus 0.035, and that's going to be raised to the t. So we probably simplify what's going on inside the parentheses a little bit better. So we'll have f of t equals 2,500 times 1.035 to the t. Right there is our exponential function that's going to model the situation. So that's part 1. Now we have to find the value of the investment after 20 years. So that's when our time t equals 20. So we're trying to find f of 20. So f of 20 is going to equal 2,500 times 1.035 raised to the 20th power. So let's grab the calculator here. I'm going to do 1.035 raised to the 20th power first. It's 1.98978. So multiply that by 2,500, and that'll give us our final answer of $4,974.47. So there is our second part of, that's our answer to part 2. Part 1 is right there. So our model function, f of t equals 2,500 times 1.035 to the t power. And after 20 years, our investment will be worth $4,974.47. Number 2, the average price of a movie ticket in 1990 was $4.22. Since then, the price has increased by approximately 3.1% each year. Write the exponential function to model the situation, then find the price of the ticket in 2016. Well, first we have to figure out which formula we're going to use. We're going to use the growth formula or the decay formula. Right here we have the word increased. So that tells you it's going up or it's growing, so we're going to use our growth function. Next, we need to identify A, R, and T. A is our initial amount, which was right here, 4.22. We're going to be looking for our growth rate, R. That's given to us right here, 3.1%. We're going to write that as a decimal, so 0.031. And then finally, time. And when we're doing the model function, time is going to remain t, but we're going to be asked at the end to find the price of the ticket in 2016. So t is going to equal 2016 minus 1990, so we're looking at a gap of 26 years there. So t will equal 26. All right, so let's plug these into our formula here. First, let's come up with our model function. So we're going to have f of t equals A, which was 4.22, times 1 plus our R, 0.031 raised to the t. So we'll simplify that a little bit. We get f to the t equals 4.22 times 1.031 to the t power. That is our model function. Now we need to find the price of a ticket in 2016. So we're going to find f of 26. That's what the price of the ticket after 26 years. Our starting point was $4.22. We multiply that 1.031 raised to the 26th power. I'm going to grab the calculator and do the math here. So 1.031 raised to the 26th power. That gives us 2.2117. We're going to multiply 2.2117 times 4.22. Multiply that by 4.22. And that gives us f of 26 is 9.33. So we're looking at a average movie ticket cost of $9.33. Number 3, this is kind of a weird problem to be doing right now, but number 3 says a virus has infected 400 people in the town and is spreading to 25% more people each day. It's a fictitious problem, by the way. Write an exponential function to model the situation, then find the number of people that will be infected in 10 days. So first we have to determine if we have a growth or a decay going on. So this is spreading, so it's growing. So we're going to use a growth function, okay? That is spreading, it is growing. And so we're going to use our growth function. Now we need to identify A, R, and T. Our A is our initial amount, which is listed right up here at 400. Our growth rate is 25%. We're going to write that as a decimal though, so 0.25. And our time, we are looking at 10 days, so 10. All right, let's write that model function. So that's going to be f of t equals A, our growth rate, which is 400, times 1 plus R. Our R is 0.25, and we're going to raise that to the t power. So let's clean that up a little bit. We get f of 10 equals 400 times 1.25 to the t power. So right there is our model exponential function. Now we need to calculate how many people will be infected in 10 days. So t will equal 10. So we're going to be looking for f of 10. That's going to equal 400 times 1.25 to the 10th power. Let's grab a calculator and work this out. So 1.25 raised to the 10th power is 9.313. We're going to multiply that by 400, and we get 3,725. 3,725. That is, I should put that is 3,725 people. That is our answer to number 3. Number 4, the population of a small town was 10,800 in 2002. Since then, the population has decreased at a rate of 2.5% each year. Write an exponential function to model the situation, then find the population of the town in 2020. First of all, we have to figure out which function we're going to use, growth or decay. So we look into our word problem, we find the word decreased. So we know that our population is decreasing, it's going down, we're going to use our decay function. Now we do identify our A, our R, and our T. A is our initial amount. We started out with a population of 10,800. R is going to be our decay rate. We're decaying at 2.5% each year. We're going to write that as a decimal, so that's 0.025. And finally, time. When we're doing our model function, time is just going to be t. Before our second question here, we're asked to find the population in 2020. We started out in 2002, we end up in 2020. T is going to be 18 years. So let's plug our values into our decay function. So we're going to get f of t equals our initial amount of 10,800 times 1 minus r. So it's 1 minus 0.025 raised to the t. Let's clean up our parentheses a little bit. We get f of t equals 10,800 times 0.975 raised to the t. Now we're asked to find population 2020, so we're asked to find f of 18. That's going to be 10,800 times 0.975 to the 18th power. I'm going to grab my calculator here. 0.975 to the 18th power is 0.634. So 0.634 times 10,800, and we're going to be looking at 6,847 people, and that is our population of the town in the year 2020. Number 5, we have Manny bought a brand new car in 2012 for $28,750. If the car depreciates by 12% each year, write an exponential function to model the situation, then find the value of the car in 2018. Well, the first thing we have to do is, are we dealing with a growth function or a decay function? Well, we're depreciating, which means our value is decreasing, so we're going to have a decay function. We need to identify A, R, and T. A is our initial amount. Our initial amount was $28,750. We need to find our decay rate, and it was decreasing by 12%. We're going to write that as a decimal, so 0.12. Finally, time, our model function, time is going to remain t. But when we're answering the last question here, find the value of the car in 2018. We started in 2012, ended up in 2018. That's a difference of 6 years. So t will equal 6. Now let's plug our numbers into our formula. So we'll have f of t equals our initial amount of 28,750 times 1 minus, because it's a decay function, so 1 minus 0.12 raised to the t power. Let's clean up that parentheses a little bit, and we'll get f of t equals 28,750 times 0.88 raised to the t power. So right here, that is our model exponential function. Now we need to find the value of the car in 2018, so we're going to find f of 6. So we're going to get 28,750 times 0.88 to the 6th power. Let me grab my calculator. 0.88 to the 6th power, that equals 0.4644. So I'm going to multiply 0.4644 times 28,750, and that's going to give me $13,351.62. So there is my answer for number 5, $13,351.62. So hopefully going through these 5 problems together, hopefully if you were stuck on any of them, or if you were confused where you might have gone wrong in one of your questions, hopefully this cleared it up for you. If you're still stuck or if you still have some questions, please email me.